5. We're back down to some skill solving. This is going to be really straightforward. The things we're looking for in this section is maintaining a really nice rigid structure. Again, students who are doing that are doing this really successfully, so let's go. All right, so we got to solve this triangle. So first of all, we'll start with this. We know that the reference triangle ratios have to be the same as the actual triangle ratios. Um, Reference triangle ratio, actual triangle ratio, that means we have to pick a reference angle, which we're going to do right here. I'm going to pick 51, but more importantly, we have to pick like the pieces relative to 51. So right away, I'm going to label them. I'm going to call this H. That's for hypotenuse. It's hypotenuse because it's crossing the right angle. I'm going to call this one OP because it's going to be the opposite, and O looks too much like 0, so OP makes more sense to me. Now we can probably throw in one more quick solve step right here, which is going to be this angle. So right away, if that one's 51, I'm going to guess this one has to be in the neighborhood of 39. 39 plus 51 makes your 90. So that's going to be the other half of that triangle. So the angle's out of the way. Let's solve for the sides. So if we're going to be solving for OP or H, we have to realize we have to use a side we already have. I can't solve for OP and H in the same step. It's not going to happen. I know I'm going to attempt it. So I'm just going to pick one. Let's solve for OP first, all right? So if I look at 51, OP is opposite, 18 is actually adjacent. And so the ratio I'm going to use in this case will be opposite over adjacent. I could flip it around if I wanted to, but I want to. And that's going to be for 51 degrees. All right. Now that should match the ratio of my actual triangle over A for 51 degrees. And now we can immediately start pulling the pieces from our actual triangle and our reference sheet into our diagram. So the actual one should be OP over 18. We have to go to our reference sheet. Okay. So 51 degrees is past 45, so I'm going to read from the bottom up. So 51 over A is actually its first column. That's really convenient. Over A for 51 is 1.2349. So 1.2349. Okay, now you didn't see me write that, of course. Let me pull my trig sheet away so you can see it. So that's the reference ratio. OP is my actual. Now let's solve. I'm going to use cross multiplying here. So OP times 1 is just my OP side, and then it looks like I just have to do a quick calculation, which in this case will be 18 times 1.2349 for my reference sheet. Multiply that by 18. And so we have 22.2282. Now, if we kind of do some quick observations here, that should make sense. OP is actually crossing the bigger of the two angles. So it should be bigger than 18, and it clearly is. Now, to find H, I could do Pythagorean theorem if I wanted to. I don't really want to. I'd much rather use trig again. So let's go ahead and solve for H. Again, we're going to start with reference triangle is equal to my actual triangle. Now, I have my my adjacent side, which is 18, and I'm trying to find my H. So I think I'm going to use A over H. I'm still going to be referencing 51, and this is going to be A over H again for 51. Okay, so my actual triangle A over H is going to give me 18 over H. Let's go to my trig table to figure out. Ooh, you couldn't see that. I apologize. So there's the rest of that. All right, so let's go to my trig table to find out the A over H for 51. Okay, 51 again is going to be read from the right. A over H is going to be this first column. And so A over H for 51 is 0.6293. All right, so now again back to the algebra solving steps. I'm going to go ahead and use cross multiplying to accomplish this. So 0.6293 times H is equal to 18. So I'll divide both sides by 0.6293, and that should give me my solution. All right, put my calculator. All right. So 18 divided by 0.6293 gives my hypotenuse value to be 28.6032. Okay, so again, before we move on, I want to note that we have all the pieces. So we have the extra angle plus two sides. Hypotenuse is the biggest side. Next biggest OP is across in 51, second biggest angle. So that should actually work out okay. So now let's move on to this guy. Let's solve these triangles. So again, we have two triangles. We just want to find the missing pieces. I'm going to go ahead and do the angle first because that seems to be probably the easiest. If that's 80, that's 90. That's got to be 10, right? Because that makes the other 90 degrees. If that's 80 and these are both right angles, that means this has got to be 80 degrees here. And so we have very few pieces left that we actually have to solve. So to kind of simplify this, I'm going to kind of designate this first one my red triangle. And designate the second my blue triangle, if I get blue here. So we can maybe pull these apart, or at least maybe give you guys some color coding to help you kind of decide what's what. Now, if I look at my red triangle, I'm missing two pieces. If I look at my blue triangle, I'm kind of missing everything. So we definitely have a lot of work we got to do. Let's label everything first. I'm just going to call that one X. I'm going to call that one Y. I'll call that piece Z. Let's keep that for now. I might need to change some of those later, or at least add to them later, I should say. But let's start there, okay? Now, it seems to me that red's going to be the easiest one to start with because I'm given a full hypotenuse value. I'm given an angle, actually both angles at this point, so it definitely feels like I can solve for x and y pretty fast. Let's go ahead and do that. Okay, so if I'm going to solve for x, it's a routine at this point, so reference triangle is equal to actual triangle. Let's pick a ratio based on 10. Well, now I'm going to have to use hypotenuse at 21 because it was given to me. And we're trying to find x. Well, x is going to be adjacent to 10. And of course, I have my hypotenuse. So I have adjacent over hypotenuse for 10 degrees. That's for my reference and also for my actual. Okay, so in my actual triangle, adjacent over hypotenuse would be paramount to x over 21. I have to go to my trig sheet to find a 10-degree angle way up here. 10-degree angle, A over H is going to be the second column. So it's going to be 0.9848. Okay, and now, again, let's use some algebra to solve this. Let me rewrite it up here. So 0.9848 equals x over 21. Instead of doing cross multiplying here, let's just multiply both sides by 21 because it'll accomplish the same thing. Grab old Mr. Calculator here. 21 times 0.984. Okay. And we have x to be 20.60. Oh, geez. Try it again. 20.6808. Okay. So that's for x. I'm going to follow a very similar solving pathway for y. Okay. Now we do have x here, but I'm going to kind of ignore it. I'm going to use the same reference triangle is equal to actual triangle ratio. Except now y is opposite, so I'll be switching that to opposite over hypotenuse. I still want to use 21, but I'll still use 10 degrees for the angle. Okay, my actual triangle, that'll give me y over 21. So I need to find over h for 10. So 10 degrees over h is my first one, 0.1736. Okay. Now as far as solving here, I'll pull the same trick I pulled before. Multiply both sides by 21. So 21 times 0.1736. So y, so y is equal to 3.6456. Okay. So I have x, I have y. Now I don't have everything else. But to solve anything on the blue, I'm going to need like a full value of some side length of the blue. which I don't have. I have all the red pieces now, but what I don't have is the blue. Now, um, if you're savvy here, you can pick out that I am giving you this much of one side of the blue, and so if you were to add this to x, you'd get a full side. Now I do have x, I solved it for right here, so this entire side would simply be the x value plus 5. Okay? And so this value is actually going to be 25.6808. Now, as soon as I have that information, I should be off and running. I should be able to find the other two pieces. And so again, that's z. Now, I didn't call this anything. Let's call this something now. Let's call this w, and w is going to be that entire side length. So we had to find these two again. So let's go to w first, just because that's what I feel like doing. W is going to be, again, I need to pick a reference angle. So let's see, reference triangle is equal to actual triangle. I'm going to use 10 degrees again. I have the full bottom, which is my adjacent. I want to find W, which is hypotenuse. So adjacent over hypotenuse for 10 degrees seems appropriate. Again, adjacent over hypotenuse for 10 degrees. Now, I actually have that value right here. I found adjacent over hypotenuse for 10 degrees earlier. So I'll just transfer that, 0.9848. And my actual adjacent over hypotenuse would be 25.6808 over 21, which is my hypotenuse value. Oh, I'm sorry. No, that's totally wrong. Over W, which is the hypotenuse value. I don't know what it is yet. 21 is just a part of it. So cross multiply seems to be in order here. So 0.9848 W is equal to 25.6808. All right. So to actually solve, we'll divide both sides by 0.9848. So W is equal to 5. Okay, so W is going to be equal to 26.0772, which is rounded, of course. Well, that's my entire hypotenuse side, only leaving Z. So let's go ahead and solve that bad boy. For Z, now again, I'm going to use 10 degrees. I'm going to use the bottom, which is my adjacent, but now Z is actually my opposite. So reference triangle equal to actual triangle. Opposite over adjacent for 10 degrees. Should be the same as opposite over adjacent for 10 degrees. Now in my actual triangle, that's Z over 25.6808. Let's go to our reference sheet for opposite over adjacent for 10.1763. Okay. So now let's actually solve this guy. Instead of doing cross multiply, I'll just multiply both sides by 25.6808, which will essentially cancel those, right? Because that goes to 1. And then I multiply that here, which I'll write kind of sideways, 25.6808. Multiply those two together. So Z in this case is equal to 4.5275. Okay, looks like we have all our pieces. Again, if you kind of look at the triangle pieces themselves, that should work out really, really well. All right. One last one for this set. Solve the triangles. Again, just find all the missing pieces. So let's go ahead and do some labeling first. Let's call this side A. Call this side B. I'm going to call this long side C, and call the little inside one D. I already have 14, which applies to these two of the triangles. So we just have to get to work here. So we have to kind of decide where to start. Um, I'm actually going to start with the angles because I think that'll give us some more options later. Um, Now, that's 90. We have a 90 here. If that's 26, given the triangle sum theorem, that should be what, 64? 60, 70, 80, 90. So that's 26 and 64. And this is also right angle. Again, that was a correction that was given to you in class. That means 64 degrees should be here. It's 26 and 64. So that's 26 here as well. 26 and 64. All right. So this is nice because again it gives us options. Now that we have all these angles and 14 applies to multiple pieces, like we can just start going to town trigonometrically. So let's just solve in order. I'm going to solve for A. Okay, so solving for A, I have 14. A is a hypotenuse, and I'm talking about the hypotenuse of this triangle. And again, if you're kind of looking, there's lots of different ways you can accomplish this. But 14, A is a hypotenuse. 14 is going to be either adjacent or opposite depending on the angle I pick, which I need to go ahead and do now. I'll see. Reference triangle equal to actual triangle. Let's go ahead. I'm going to use 26. So 14 is going to be opposite. A is going to be hypotenuse, so it's going to be opposite over hypotenuse for 26. Is going to be equal to, of course, opposite over hypotenuse for 26. Oh, man. Sorry about that. I don't know how long that's been up there. I was probably up there for this part right here. I apologize about that, guys. There's the remainder of that problem. Sorry about that. Yeah, I pulled the value 0.1763, and I just went to solve, and that's the end of that one. Okay. You missed the introduction to this one, so let me kind of recap what I just did. I had to solve both triangles, so I went through and I kind of labeled everything. The next thing I did was start to put in some angles. So this one is easy, 64, because of triangle sum theorem. But if you understand this is a right angle, that's given to you in class, that makes that angle 64. And my triangle sum theorem makes the top 26. And that's important because that gives us multiple places to actually access a reference angle. And so to solve for A, in the median triangle, even though I know A belongs to multiple triangles, I'm going to use A in this case first. So I'm going to use O over H because I'm going to use a 14. A is going to be the actual hypotenuse. And so that should match my O over A for 26 degrees here as well. So my actual triangle, A is going to be my hypotenuse. Oh wait, hold on. There we go. Okay, so over A, so 14 is my opposite. A is going to be my actual hypotenuse side. Let's go to our reference sheet, and I'll hopefully remember to pull this away this time. Over H for 26. Over H is the first column, 26. Boom, there it is right there. 0.4384. Okay, so let's go ahead and continue to solve for A. I'm going to pull over 1 so I can do some cross multiplying. So 14 is equal to A times 0.4384. So algebraically speaking, let's divide by 0.384 on both sides. So A in this case is equal to, our calculator, 14 divided by 0.4. So A I have as 31.9343. Okay, so one piece down. Let's keep on moving. Let's solve for B. Okay, so for B. Now for B and for D, again I could consider maybe the biggest triangle here, but I'm going to take this small one just because I think it's easier. Let's see. The reference triangle is equal to actual triangle. We have to pick a reference angle, and we have to start picking sides. We had to involve 14 again because 14 is part of this smaller triangle. I'm going to use 26 as a reference. I did the same thing in the last one, I believe. So 14 looks like it's going to be the adjacent. B will be the hypotenuse. So I'm dealing with adjacent over hypotenuse for 26. And that should be the same for both triangles because if they're similar, the ratio should match. The actual triangle adjacent is 14. Hypotenuse is B. Let's go to our reference here. A over H for 26. A over H is actually the second column, so I need this number here, 0.8988. Okay, now this is cross multiplying. All right, so 14 is equal to 0.8988 times B. So let's divide both sides by 0.8988. Okay, so B shall be equal to 15.5763. Okay, so we're just going about our business solving, so let's go ahead and solve for D while we're at it. Okay, reference triangle is equal to my actual triangle ratio, which of course is true for all similar triangles. We're going to use 14 again. I'm going to stick with 26, so it makes 14 still my adjacent. D in this case is my opposite. So let's go adjacent over opposite for 26 degrees. Adjacent over opposite for 26 degrees. And I could have reversed those, but that's just the one I chose. Now my actual triangle, my adjacent is 14. My opposite is D, which I'm trying to find. Going to our trig sheet. Adjacent over opposites is actually the very, very last column, so I need this number. So 2.0503. Okay. Let's pull algebra again. So boom, let's go ahead and cross multiply. So 2.0503 times D is equal to 14. Solve algebraically. Let's divide by 2.0503. Okay, so D is equal to, oh man, I did it again. Sorry about that. So I just pulled the number and now I cross multiplied. So I ended with 2.0503D equals 14. So of course dividing both sides to cancel that one. So D is equal to 6.8282. Now we're almost done. We just have to find one more side, which is actually C. Now I'm going to switch gears a little bit, and I'm going to think of C kind of in terms of like this big triangle. Okay. Now, interestingly enough, I'm still going to use a reference angle of 26. It's been working so far, so why change? If I'm sitting at 26, that makes C the hypotenuse, which means I need another side. I need A or B. Now, I found both A and B. They're sitting actually right here. It doesn't really matter which. I'm just going to pick A. So let's go ahead again to the solving for C. So I'm going to use A and C. So A is my adjacent. So let's see, reference triangle is equal to actual triangle. So adjacent over hypotenuse for 26. This should be the same for my referencing angle or my actual triangle. My actual triangle, my adjacent, which is A, which is right here, is 31.9343. Hypotenuse is unknown, so I'll leave that as an H. Going to my trig table, A over H is the second column, so 26 second column should be 0.8988. Now, of course, solving this algebraically, I'll throw this guy over 1, cross multiply. So h in this case will be equal to 31.9343 divided by 0.8988. So my hypotenuse, the biggest triangle hypotenuse, is 35.5299. Okay, that was a bear of a problem, but hey, sometimes the problems are going to be a little longer. The point of being in a problem like this, if you felt really good about it, like what you're showing me, is that you really kind of understand the dynamic nature of these 3 pieces, and you certainly have the mechanics to get through a tough problem. Oh my god, I did it again. I'm so sorry. So, dang it. To solve for C, okay, I have 0.8988, and I just did some cross multiplication to get the value of h to be 35, okay? I'm sorry, guys, it's about 11 at night, and I am tired, and that is what's going on. Sometimes when you solve math and you're tired, you make mistakes like that, which I'm sorry for. Anyway, that has to do with this video. I believe this is part 5, so I'll see you guys in part 6.